Sounds
So,
good.
welcome to the last talk of GDevCon. We prepared a very nice, light-hearted presentation for you to give you a little, a story about two developers trying to distribute their code, trying to share their code, and the experiences they make on that journey. Maybe to start off, who are we? My name is Jan Göbel. I'm a senior support engineer at NI. I started at NI in 2014. I'm a CLA, CTD, professional instructor. Been working with LabVIEW for 12 plus years now. And my hobbies, I kept them very general, are AI stuff, music, coding, a bunch of other things. Feel free to ask me later on about that. How about you, Chris?
So, Chris Roebuck, I'm the new guy. I've been with NI for 1 year, but I've been using LabVIEW since 1994. That just means I'm old. My hobbies when I'm not working really hard, take notes, Eli. When I'm not working really hard, I spend my time playing golf and building LabVIEW tools with the project provider. So yes, I'm some kind of crazy person. So when we talk about the LabVIEW community, we talk about LabVIEW friends, and honestly, it sounds a little cheesy, but I think about a lot of people in this room almost like family. And last year in Stuttgart, I stood on the stage and I announced myself joining NI, and I got a great reception. And I also emotionally explained how my son was leaving home to move to Cardiff University, and he would be studying mechanical engineering. And everybody was like, yeah, that's really cool. And I said, I hope he takes a LabVIEW class or something. Imagine my delight when on the first day, he showed me this poster from the top of the stairs in one of the engineering labs. Now, it's a little dated, I concede. The logo's not quite up to date, but I was super enthusiastic to see that. Imagine my sheer delight on the second day when he was in a laboratory and he sent me this picture. He said, hey, Dad, we're going to be using LabVIEW, and there's this Elvis thing. And then he kind of sent me another message saying, oh, that's... we're going to be using Python, actually, but that's beside the point. I should say, since then, the pictures and the messages he's been sending me, they've been kind of declining somewhat in quality. I think since week one, his priorities have changed. What I'd really like to do is get everybody back in a year's time, and maybe we can see how that first year worked out and whether he did do any LabVIEW. So as Jan said, we're going to be talking about a scenario today. A very much a light-hearted, let's not take ourselves too seriously. We're at the end of GDevCon. I hope we've all had a fantastic week. But we'd like to look at a scenario. I'm a test engineer, and I'd love to spend all my time attending conferences like this and hanging out with LabVIEW friends, but it's not always possible. Sometimes I've got some work to do. And in this particular instance, I'm building a new test system. I know that as part of building that test system, I'm going to need to be able to control that power supply.
Did you say that power supply?
Yeah, that one. I'd really appreciate it if you knew of any reuse library or something that I could use to get started.
Yeah, actually, I've been using it last week. Like, I used that power supply for the other project. I created a driver. You need it.
That would be great.
All right. So, I mean, it's done. How should I send it to you?
Zip file seems like a good idea.
Okay. I mean, that's an easy start. Let's see how zip file works. I mean, I think everybody knows. Just right-click, compress the zip, and I can send you an email with it.
Okay, so while I wait for Jan's email to come through containing his zip file, oh, there it is. So I'm going to download that zip file from the email. He didn't tell me where to put that zip file. I'm just going to create a folder and dump that zip file in there. Let's extract it. I hope it's the right place. He didn't tell me what to do with it. Let's have a look inside and see what we've got. Okay, looks like we've got some VIs in there. That's kind of nice. And we've got a library in there as well. Let me open that library and take a look at it. Oh, an API. Those functions look familiar. I can control the voltage. I can control the current. Oh, even nicer, he created me some examples as well, so I know how to get started. Well, let's have a look at those examples. Let's see how I can get started. Oh. Uh-oh. So something kind of went wrong. What am I missing? I'm missing a math library. A math library with a power supply, okay.
Yeah. Didn't you have my math library installed?
No.
Oh, okay.
No, okay.
Yeah, there's a volt to millivolt function in there. It's very important. I'm using it many projects, actually.
Somehow I didn't get that. So, yeah. Okay, well, while Jan figures that one out, maybe I can take a look inside and see if I can take a look at what's going on, what he's doing with that function as well. Maybe you could build that for me whilst you're not doing too much. So I'm going to go and look inside and have a look at the code. And actually, I can fix that code myself because he just sent me the source files. I went in, dug around a little bit, and yeah, I went in and found the missing math function. Can't be doing anything important, can it? Numbers and a power supply? I'll just use the diagram disable function. That's going to fix things for me. Let's put that round that missing function that he didn't bother to send to me. And, okay, I fixed it. My power supply is now fixed.
Yeah, fixed.
So, in summary, Jan sent me the power supply driver. It was super easy. He just sent me some code. I didn't need any additional software. Every operating system supports zip files and their extraction. Super straightforward. If I really wanted to, as I mentioned at the beginning, I'm old. I like using the palettes. Quick drop, that's what the new cool kids are using. I'm old, I use palettes. If I wanted a palette, I could take that code and I could put it in user.lib and auto-generate some palettes for me. But Jan didn't have any control over what I did with that code or where he put it. And as we saw, we had some missing dependencies. We also saw that the code could be edited. That might be deemed a positive or a negative. From Jan's perspective, it was super negative because I went and messed around with his code and changed something that could have been dangerous. There was no version control. That zip library had no version associated with it. Of course, the library inside did, but from the zip file on disk, I couldn't tell what version I had. It was kind of freestyle distribution as well. He sent me an email. He could have put it on a website or a network share. So we need a way of including those dependencies. Jan, do you think you could do something for me?
Yeah, absolutely. I did my LabVIEW Core 1 training last week.
Nice.
And I learned some cool stuff there. There's something in LabVIEW called a source distribution. Have you heard of it?
I haven't, no. It
yeah.
must be a new thing.
Yeah, absolutely. Basically, in a LabVIEW project, you can just create a build spec for a source distribution. You can give it a name. You can define a source folder where all your code is inside. And you can include it into your build spec, build it, and then you have all the dependencies automatically included in your resulting build folder. So basically, we have the useful math library in there. We have my driver library in there. I can, again, just zip it for you and send it to you via mail. Is that fine?
It sounds good. What could go wrong? So, while I wait for Jan's email to arrive, let's try this newfangled source distribution of which he spoke. So, we got a zip file because he's still sending it to me as a zip. I'm going to go and extract that. Again, I've got no knowledge or understanding of where I should extract it to, but I'm just going to put it in a random folder. And this time, when I look inside, I can see that missing math function, that missing math library that caused so many problems previously. It's in there, so I should be good to go. I can still see the power supply library as well. I can see the API. I can see all of the examples. I can also see that that library has a version number. That's the version number of the library. The source distribution itself also has a version, so how do I find out about that version? That's a question I need to ask Jan a little bit later and figure out versions of what. But let's take a look inside the code of that source distribution. It runs. It's not broken like the original version was, so obviously the dependencies were included. I should be good to go. But it's still editable, and where do I put it?
No. Huh?
Don't change it?
Yeah, don't change the code. That's not, you shouldn't do that.
Okay, can you tell me where to stick it?
No, I'll keep that for myself, but you will figure it out.
Okay, so source distribution, super easy. No additional software required. Dependencies included, yay. But the code can still be edited, and we've still got this freestyle distribution method going on. Also, I'm old. I'd like some palettes, please, Jan.
Okay, it's pretty tedious to do the palettes. You have to go like super deep menu stuff, then create a menu file, put it at the right place. You really need that?
Yeah, I really need that.
Okay. Actually, I was talking to some people on the conference yesterday, and I learned about a new tool, or it's not that new, but a very nice tool from JKI called the VI Package Manager. And it actually features palette generation. So I can show you. So you can just build a VI Package Manager build specification, similar to what you would do in LabVIEW, and give it a, maybe run the video. Open the VI package build spec, and you can define a source folder where your source files will be included, just as with the source distribution. You can define an output folder. You got versioning, you wanted that so bad, and it's even automatically increasing your build number, which is quite handy, so you get a new build every time. It will feature a bunch of metadata, descriptions, and of course, you will have a palette, and it's automatically generated for you. It takes all the VIs that you have. You can manually, of course, modify it a little bit. So that's quite handy, I would say. You can also do a lot more with it. Like you can put files into help files. You can do custom probes, all kind of stuff. Like you can add all kind of LabVIEW related files to it. You can even define other packages as a dependency. So I could have maybe splitted it up even to have my math library be its own package if I wanted to. And there's all kind of other settings that you can set, like pre, post build actions, settings for the installation, and so on. So it's a very useful tool. Should we give it a try?
Sounds good.
All right. Yeah, then I can just build the package and send it to you via mail.
Oh, so while I wait for Jan's mail to come through, I'm going to receive this. Oh, it's not a zip file now. It's a VIP file. Wonder what I can do with that. I wonder where to put it. So I'm going to open it with this newfangled VI package manager tool that Jan's introducing me to. I'm going to say, go ahead and open that package. And it's going to actually ask me if I want to install it into my library. It's got some version information straight away. So unlike that source distribution and the zip file example in the beginning, we're starting to actually control revisions and understand what the changes from one revision to another might actually be. I want to start using it. I've installed it, and yeah, I love palettes, me. So there we've got those palettes with the API functions. He's created a really nice sub-palette with the examples for me to get started, and I can start programming with that driver immediately. I can see as well the examples they worked out of the box. So when he built that VI package, it pulled the dependencies in. As he said, you could actually list them as by reference dependencies and have them be in their own package, but it pulled them in. I have everything I need to start working. Also, I didn't need to worry about where to extract it to or where to put it. Jan was in control of that. He determined where it should be installed to, whether it be vi.lib or the toolkits folder or some other destination on disk. If I look on disk where it actually put it, it also included the dependencies as well, so no dependencies for me to worry about. So I'm going to start using this driver for that power supply, and let's have a look. Oh, I'm editing code again, sorry, Jan. I'm going to go and see what happens if I multiply that voltage by some number. Nothing bad can happen there, right?
Is that how you include your scaling into drivers?
It's how I do it, yes. So we've made a small change, we've made some code, I've still edited. So that's a potential weakness of this. Or is it? Well, small diversion ahead. If we go back to VI Package Manager and we take a look, we'll see some options in the source file settings page that allows me to lock or password protect a block diagram. There's actually a really nice feature in there where I can set a randomized password so the developer of the package can't actually cheat and go and unlock that code, make a quick change to the deployed version. They have to do that. They have to rebuild the package again. So they go and modify the source and then rebuild the package. That's super nice. Other thing that I wanted to draw your attention to is the renaming. One of the nice things that you can do is, as part of the package build process, you can actually programmatically rename your source files. Why might you want to do that? Well, let's say I'm using that power supply driver that Jan created for me, and I'm using it in a project, and I realize I want to change something. I want to change that scaling, sorry, Jan. I can actually go and take the source, and because the installed package has a prefix, it effectively has a different name. It has its own namespace, and the VIs have different names. I can actually go and open the source whilst my development project is still in memory, not get any naming collisions. So I can go and modify the source, rebuild the package, install it, and I've got still got my project active. So that looks really cool. Lovely palettes. Did I mention I really like palettes? Dependency management, version management. So each package has a version, and I can install different package versions for the different versions of LabVIEW that I may have installed at any given time. The code can still be edited, but I'm going to put a little asterisk next to that. If you go and talk to the lovely folks at JKI, they will sell you a version of VIPM that allows you to protect that code. Negative, it's a third-party solution. That might be an issue. It's not an issue for me. Is it an issue for you, Jan?
Oh, it's not a big issue, but I heard about another way that we could try to protect our code if you're interested.
Yeah, I'd really like to protect the IP.
Yeah, so there's another thing made by an I called the packed library. So maybe you've heard about it. It's similar to a source distribution. You can create a build spec for a packed library. The only difference is you definitely need a library as the source, so you cannot include like just single VIs. But basically you name your build spec, you name your build output, LVLibP, and you define a library as a source, and you build it, and then I can send it to you as a single file, which is the handy thing, and it will also include all the dependencies. It will, by default, remove all the block diagrams from the VIs, so you cannot edit it anymore. It's a nice thing.
Does it have to do that?
It doesn't have to. You can keep the block diagrams if you want. You can set that, of course, but by default, they're gone. So by default, your code is protected. You have a single file to distribute, and you can just, or I can just send it to you over via email.
Sounds perfect, right? So let's take that file that Jan has emailed to me kindly. Kind of feel like I've taken a step backwards though now, because now I need to know where it should live on disk, where it needs to reside. Oh, okay. But wait, I'm using the latest version of LabVIEW. I've got 2025 Q3. What did you use?
Yeah, same. 25 Q3. That's weird.
Okay, well, we'll come back to that in a second. Any benefits to this? Well, if I right-click on my libp, look at the properties, I can see it has a version number. That's nice, and it shows up in the OS, so that's super cool. So it's been versioned. I'll try 64-bit LabVIEW. Maybe I'll have some luck with that.
Didn't you use? I mean, it's 2025. Of course, I've used 64-bit.
Yeah, I'm old. So let's have a look inside. We've opened the libp, and we can see the API. We can see what our power supply should be doing. We can see the examples as previously, and they're not broken, and it runs out of the box, so no missing dependencies. This is cool, and it's protected. I can't edit the block diagram. You're happy with that, right, Jan?
Yeah, very
Okay,
happy.
where's my palette?
Oh, there are no palettes.
So, in summary, with the Pack project library, positives, performance. I heard that they're compiled code, so they're more performant. The code is protected. The IP is hidden unless we override that. My LabVIEW dependencies are included. We've got some versioning of this. I heard they had kind of a complex build process when they use object-oriented programming.
Yeah, especially if you go for plugin architectures or something, but that's why I just didn't use OOP for the driver.
Kind of version sensitive as well, and bitness sensitive, so that's something to be aware of. Or maybe we should just talk the next time and make sure we're using the same version. Palette integration's not automatic. Jan, I really need my palettes.
You really need them?
I know it's
tedious to do that. But actually, maybe we can combine, like we already had the VI package manager that can do palettes quite easily, and maybe we can combine the benefits of both.
Sounds good.
So we can just build a PPL and put it inside a VI package. That would be quite a nice way. So we basically have our packed library already done. We can create a new VI package build specification, add the folder to our where our VI package is at, where our library is inside, add a product name. create the build spec. And then you will see that we only have right now the packed library in our build spec. So when we look in the overview, we won't see all the VIs of the packed library, which is, yeah, a little bit more tedious than the way before, but it's still doable. So we can manually add our functions palette and insert the VIs from the packed library as single VIs to that. It's going to be a few clicks, so that's why I'm not running through all of them. But this way, you can have all the benefits of a packed library. You can have the performance, all of that, inside a VI package. I'm doing the palette for you, so it's not the work that you need to do. I can build it and send it to you via email.
Sounds good, although that looked like quite a bit of work, Jan, but thank you for that. So let's take that. So what am I going to get this time? I'm going to get a VI package, so I know I don't need to worry about where to place this. Jan's already specified where it should get installed, so let's go ahead and install it. We've got the versioning that we talked about. Really nice thing there that shows me where the package, once it's installed, will reside in the palette. Did I mention I really like the palettes? So that's going to go ahead and install, and in the true tradition of videos, it's a little bit faster than in reality. We're installed, we're going to, come on. Yep, and we're installed. Package has independent versioning, so that package version is independent from the version of the library contained within the package. And let's go ahead and use that now in LabVIEW. Let's look at the palettes. Did I mention I like palettes? That power supply. We have the palette, we have the examples, we're going to drop those down and start using those examples immediately. And out of the box, they are ready to run, they contain all of their dependencies, and the IP is protected, so nobody can go in and tinker and change that scaling value. Looks pretty good, actually, Jan. I'm happy with that. And on disk, all of the dependencies have been included. Maybe we do a summary? Mm-hmm. So, positives, everything from PPLs, everything from VIPM when combined, you get all of the goodness of both, dependencies are included, you get those lovely palettes. It's third-party software, that may or may not be an issue for you, you just need to be aware of it. It's not an issue for me. It's potentially paid for if you want some of those features, but honestly, it gave me everything I wanted, so I'm ready to start building that test system. So, we've shown several examples there. Does that mean everybody needs to go out and start building PPLs and putting them inside VI packages? No, it doesn't. Really, it comes down to what it is that you are building and distributing and who you are distributing it to. So for example, if I've got some LabVIEW code and I need it to be editable, maybe I'm sharing it with some team members for them to contribute, then a source distribution gives me that opportunity. It gives me everything that I need as a dependency, but it still allows me to edit, make those changes. How do I distribute it? Perhaps I distribute it by email like Jan did to begin with. Maybe I build a VI package so that I've got less things to worry about. I don't need to worry about where to place it on disk, get those nice palettes that I mentioned. Where does it go once it's in a VI package? How do I distribute it? As I mentioned, email. We could make it public and put it on vipm.io, but then it's public, so other people share. If I need it to be contained within my organization, then there are some options for VIPM, enterprise, etc., that the lovely folks at JKI will talk to you about. If I need to protect it, then I'm probably going to go down the packed library route so that we've got that IP protection and the performance. Again, the distribution question remains. Do I build it into a VI package? Do I simply email it? Anything else, Jan? Any other options we have?
Yeah, maybe to just like make this chart a little bit fuller than it is already. One thing we haven't been talking about till this point is what's happening to your project once you finished it, like once you build an application out of it. Like that's a different path of code distribution that we could have a look at. We're just mentioning it here shortly. So basically we would, of course, build an EXE, and then we could use the NI package manager, that probably many of you know, to install that application to customers, to internal stakeholders, things like that. And if you need a customization, there still is the feature to have a LabVIEW installer, which has been around for a while. And that one you can add custom logos, you can add custom license information, all that kind of stuff. So it's still a pretty valuable tool if you're really trying to distribute and sell your code or really bring it to the market. And one more thing maybe to mention to even make this a little fuller. We've been looking at VIPM Public, VIPM Pro. We could send our packages out via email. We could also use a network drive. We could use a website to download them. There's all kinds of ways. And of course, there's another way that's definitely worth mentioning. Like we can have all of these options and always put them in a Git repository and then just distribute it that way. But that's like a whole nother chunk of talk. Maybe that's a topic for next year, Chris.
Yeah, these people have to come back again and hear us again.
All right. Then, by that, I hope that was an interesting adventure for you to visit our two developers, how to share their code. And yeah, thank you very much for listening.
Time for questions.
Any idea or just any plans about installer update in LabVIEW? Sorry, but probably plenty of people also stuck with this. It is
so. Are you talking about the custom installer? Because yeah,
for example,
basically, who needs
Elijah Carey, everybody.
So actually, I've been.
Yeah, I can say it. Short answer is yes. So effectively, I would actually modify that graph to show that the use of the traditional WinMIF-based installer, the plan is that NI Package Manager can eventually be used as a more sophisticated tool for deploying end-user software to your end clients. However, before you get upset, like there's lots of things that the current installer technology does that it does not yet do, like custom licensing, custom branding, and logo. So the tentative plan is that it needs to support all of those workflows, at which point we expect it will replace the historical WinMIF-based install technology as the vehicle for distributing software. And the reason that's awesome is then you make some seemingly small innocuous change, you don't have to rebuild the entire installer, it uses packages. So you can then specify like, here are my dependencies, here are the feeds they come from, and it can resolve whether or not they're already present on the system. So there's a lot of advantages when we eventually replicate all of the functionality of the current installer in NI Package Manager. So that's the plan, and I offer you exactly no dates on when that will happen.
May I see some hands? Who is using custom installers in that way, like really customizing them? So that just, well, it's quite a few people.
Wait. Oh, this is actually so relevant for me.
Yeah, that's why I wanted to ask that.
Hold your hand up if you're creating custom WinMIF-based installers today. Big, tall hands. Come on, please. Okay. See, Greg and Jeff, this is market research at its finest. By the way, can I throw something out there? There's an interesting, I've seen people use source distributions to distribute binaries. Because you can strip out source and specify keep the compiled object cache only. And there's another way to do it as opposed to a PPL. The only downside being it's a ton of files on disk, but effectively the same and negates some of the complexities of the linker. So just a fun little
nice.
pro tip.
Can you let me know their company ticker so that I can short them?
There is one inconvenience here. All these steps have own version numbers.
What again, please?
Each step has own version numbers. For development, it's great. For user, it's terrible because user look for version number and he doesn't understand what does he actually install. Maybe we fixed code which he installed. Maybe we fixed installer. It must be somehow logically assembled in one information block. What is inside and what is installer? This LabVIEW installer, it has 3 numbers. LabVIEW code has 4 numbers, and they can be completely independent. And this is quite confusing for user.
Oh, the versioning scheme of...
Yeah, so basically, yeah.
Yeah, so when we switch to package-based technologies, then you have the package version.
Exactly, then it's only the package versioning that's left, so basically that should be where it's going, so...
Do you realize you made everybody in here an NI employee?
What?
Yeah.
They all have to sign NDAs before they leave. No, just kidding. That was, yeah, I do that all the time.
There is one more problem. Packed libraries only have a version on Windows,
Not
not on Linux.
Yeah, we were actually covering Windows only, but that's a very good addition.
Because on Windows they are packed into a sort of PA header or wrapper, and on Linux it's only the original fast format or something it's called.
Okay, wasn't aware of that. Very good addition, yeah.
No.
That's true. Yeah, great.
There's no version visible to the file system.
Ah, okay.
On the topic of dependencies, criteria was where to install it, and VIPM only installs into, well, the common LabVIEW folders. But we do manage projects that are complicated, so we usually like to have our dependency close to our projects. And there has been some work on that, and we have seen also some experimental work from some people, and it would be cool to see like this graph extended in that way.
Yeah,
So
actually, that's the idea also with the Git approach, to go with other approaches of distributing code, which definitely would not be that, how to say, digestible as a talk anymore. But then we were talking about Git submodules, pulling everything into the project directory, for example, from the compiled code. Maybe next year.
Plus, in the source file settings in VI Package Manager, you can specify a custom destination. So there's a little plus at the bottom of the list. You can click that and then specify a custom location, which will then appear as a destination in the drop-down list.
So another thing to add is I'm missing an arrow from packed library to NI Package Manager, because that's what I'm using. You don't have the palettes, Chris, but you get the benefit of the feeds from the package manager. So that's a good way to distribute. And you get, as Jonathan was saying, more freedom in where to install it. So what are your thoughts about using that, that way?
Mm-hmm. Yeah, so in general, like for my head, I separate like distributing source code with VI Package Manager and distributing executables with NI Package Manager. It does work with NI Package Manager, but it's currently lacking a bunch of features compared to VIPM. Yeah, so basically, there might be situations, like if you have, for example, NI packages that are dependencies that are very relevant for your toolkit, for example. That would be one thing to do. Yeah, but in general, I wouldn't do that, but I can imagine that there's use cases for that, yeah.
Oh, I could talk for hours on that topic.
We have time.
No, just I heard several times about Git for maintaining distributed code. And to me, Git is a source code control manager, so I would not advocate at all to use Git for distributing your source code. It's not what it's meant for, even if it might work for your use case. But try to find other ways, maybe.
Right now, you're assuming that all these get put into userlib. Is that right? When you're
VILib.
VILib?
VILib.
Okay, so we should probably talk about that, right? Because the advent of the add-ons folder is a relevant change. And what was that? 2 years ago we came out with that. So that gives version independence to drivers and add-ons across multiple installations of LabVIEW. And there's actually some additional functionality that we have teed up, no guaranteed timeframes, for changing between versions of dependencies. So Greg is the expert on it, but just know that increasingly in this world of cybersecurity, modifying the contents of things under program files is unacceptable. So for a variety of reasons, you would probably want to put these dependencies in a shared space like the add-ons folder. And I don't know, Greg, if you want to edify them more on why it's awesome and what they can look forward to. But if you can catch Greg later, I think that's a recent change that's very relevant to this topic.
Yeah,
Very, very valid point. Maybe question back to JKI on that. Is it VIPM managing that?
So yeah, moving package files outside of the LabVIEW directory is very much on the roadmap. We're very aware of the security concerns of modifying the LabVIEW directory. Like Eli said earlier, I'm not going to give any firm dates, but know that it's a very high priority for custom install locations that may or may not include LVAddons.
Just going back to a previous point about Git, I just wanted to make the distinction. I've seen it done before where people use subrepos as their dependencies, and then you're tying it to a particular commit. And for some people, this works well. I'm not saying it's the answer for everyone, but I just thought I'd mention subrepos.
Absolutely, that's what was basically the Git point should be about, yeah.
Subrepos can be used very effectively. I think they work better when it's something that is also part of your development. So you're making modifications to both. I'm not a fan of subrepos for something that's not, that you don't consider part of your source code for an actual dependency authored by someone else. Personally, I don't like that model.
You're missing Dragon and System Link. Yeah, for distributing an NI package file. We don't make this graph as huge as possible.
Maybe one final comment on the caveats on using pack library for development. You can't have a public Vim file in a PPL. So if you want to distribute that, you need to go through some hoops in the VI package. You can actually add some extra stuff to make that available, but it can be done out of the box. So that you need to be aware of that.
Thanks.
So I'd be kind of interested really quickly before we finish. Quick show of hands, who's kind of routinely using PPLs as part of their workflows? Okay. So when it comes to bitness, leave your hands up if bitness represents a problem for you right now. And who works around it by having multiple packages or multiple... Who's doing the clever things like including both PPLs in a package and then having a post-install action? Okay. So a lot of workarounds right now. Okay, cool. Any more questions, I think?
All right.
Looks like that's... Oh.
Yeah, thanks very much for your presentation. It was great. Just a comment on your smart workarounds for PPLs and post actions. There aren't any clever post actions you really need to do. If you include both PPLs in different directories for 32 and 64-bit, the very nature of PPLs are dynamic, so you can choose which one you're loading in source with like a conditional disable structure. And that's been working very well for us at JKI.
I think LVAddons also.
LVAddons.
I believe LVAddons provides also ways to work around that problem, maybe in a cleaner way, or different way at least.
All right. Rolf?
Can we get one from this side next to keep Anders busy?
about the packet libraries used in different platforms and different business. There is something built in LabVIEW which already sort of supports it, but there are some edge cases where it just breaks down, especially on real-time targets. It doesn't work well. You can, in the LabVIEW development environment, you can have certain sub-libraries. It was a technology which was documented by Stephen Mercer, AristosQ, and where you have actually subdirectories per architecture, and you can put in the packet libraries in there, and then LabVIEW will choose the correct packet library based on the platform and the business. And that works almost.
Almost.
Well, there are some things if you want to distribute the code to real-time targets. On the ARM system, it worked fine. On the x64, it broke down.
Okay. Are we aware of that, or is that?
There's a document on
the correct.
So I actually presented at GDevCon NA that included some of this information, and yes, there's a targets directory. Recently we've added, it was created to support RT. Recently we've added desktop targets subdirectories underneath the targets directory, and so if you go search for my presentation from 2024 at GDevCon NA, you can learn more.
All right. Then I would say thank you very much and have a nice afternoon in the huddles.